Every AI assistant follows instructions. But what happens when it receives two sets of instructions that contradict each other? That's where one of AI's biggest security challenges begins. It's called prompt injection, and it's reshaping how we think about AI safety. We'll explore how AI processes instructions, what happens when those instructions conflict, the security risks that emerge, and how modern systems defend against these challenges. This is the journey from vulnerability to protection. AI systems don't just receive one set of instructions. They process multiple layers at once. System instructions define core behavior. User instructions request specific tasks. Everything flows into the AI's processing core, where these instruction streams must somehow coexist. But here's the problem. Not all instructions align. When instruction streams collide, behavioral tension emerges. The AI must choose which instructions to follow. This creates both reliability and security concerns that every AI system must address. Prompt injection is a security vulnerability where input attempts to interfere with the intended instructions guiding an AI system. It's not about breaking the AI. It's about creating instruction conflicts that change how the system behaves, often in ways the designer never intended. AI systems process instructions using natural language. Multiple instruction layers flow into the AI core, interact in unpredictable ways, and create security challenges fundamentally different from traditional software. There's no firewall for conflicting language. In direct prompt injection, a user intentionally provides instructions that conflict with the system's intended behavior. The user request collides with system instructions head-on. It's deliberate, visible, and creates an immediate security challenge that the AI must navigate. Indirect prompt injection is more subtle and more dangerous. Instructions arrive hidden inside external content, documents the AI reads, websites it browses, emails it processes. The AI encounters these instructions unknowingly, treating malicious commands as legitimate information it should follow. Direct or indirect, the core issue remains the same. Competing instructions attempting to influence AI behavior. Understanding both attack vectors is essential. Enterprise AI systems process sensitive workflows daily. Customer support conversations, financial operations, internal knowledge systems. When these systems become vulnerable to instruction conflicts, the operational risks multiply instantly. One compromised instruction can cascade across thousands of interactions. Organizations need AI systems that behave predictably every single time. Company policies guide the AI assistant, which processes employee requests within those boundaries. Consistent, controlled, reliable behavior isn't just a feature. It's the foundation of trust, and without it, AI becomes a liability. Modern AI systems deploy multiple protection layers working in concert. Input filters validate incoming data before it reaches the core. Guardrails constrain behavior during processing. Monitoring systems track activity continuously. Each layer adds another security control that reduces the attack surface. Organizations reduce prompt injection risk through 4 key strategies: isolating instruction types, verifying content sources, monitoring for anomalies, and building overlapping defenses. Multiple security rings surround the AI core, each creating another barrier. Human language is flexible, ambiguous, and infinitely complex. Millions of language pathways exist, each carrying potential instruction variations that could slip past filters. This natural complexity makes perfect prompt injection defense nearly impossible. There's always another way to phrase the attack. Security and reliability are two sides of the same coin. As safeguards activate and monitoring increases, trust grows. Reliable AI isn't just about correct answers. It's about consistent, governed behavior that organizations can depend on. Prompt injection is one of the most active research areas in AI security today. Security teams, academic researchers, and enterprise systems are racing to develop better defenses. This isn't a static problem with a final solution. It's an evolving challenge driving continuous innovation. Here's the complete workflow in action. System instructions define baseline behavior. User instructions request specific tasks. Conflict detection identifies potential issues. AI processing applies safeguards layer by layer. Finally, responses emerge, filtered and verified. This pipeline is where security meets functionality. Think of prompt injection as an instruction traffic control problem. Multiple instructions arrive from different sources simultaneously. Conflict management systems coordinate them, prioritize safe paths, and security layers protect against dangerous collisions before they happen. Prompt injection isn't about making AI smarter or more capable. It's about keeping AI reliable when it matters most. As AI becomes embedded in more business systems, customer interactions, and critical workflows, managing instructions securely becomes one of the most important challenges we face. The future of AI depends on solving it.